Have you ever built an AI agent that worked perfectly in your notebook and then completely fell apart the moment it hit the production? Well, yeah, you are not alone. I am also there as one of your partner. And that's exactly why we are here today. This is not a theory lecture, it's a survival guide. So you will walk away with a working agent by the end. My name is Praveen, and today I'm not just going to talk about the LangGraph, but we will look at building production grade AI agents. Picture this, it's Friday afternoon, you deploy your shiny new AI agent. Monday morning, your Slack is on fire. The agent tried to call an API, got a timeout, retried, retried again and again until it burned through your entire token budget in a loop. And the worst part, when you restarted it, it had zero memory of what it had already done. Back to square one. Stuck in loops. It's like a GPS that keeps saying recalculating but never finds the route. Lost context. Imagine filling out a 10-page form and on page 8 the browser crashes. You start from page 1, that's your agent. No recovery, no save point, no checkpoint, just gone. All right, which of these has bitten you? Uh, a quick question to all the audience who are listening to me. Maybe stuck in loop, lost context, no recovery. Well, you're not alone. So think of a Navy agent just like a junior employee with no manager, no judgment, and no way to ask for help. So you give them one instruction, book me a flight to Berlin, and then you leave the room. What could happen? Many things. Infinite retries, they can't find a flight, so they try again 200 times. Your API key is revoked, your card is flagged for fraud. Tool call explosion, they decide to check all options simultaneously, maybe 47 browser tabs, 3 travel agents, 2 airline calls, costs are spiking, downstream systems buckle. Memory loss. They found a flight but forgot why they were booking it. They booked the wrong city, Berlin, Ohio, and so on. Context corruption. They booked based on a calendar invite that was cancelled last week. Nobody told the agent. It acted on a ghost data confidently. No recovery. Halfway through, the payment API's times out. The agent just stops. No error, no message to you. The run dies in silence. Hallucinated execution. An hour later, done, flight booked. You check, nothing happened. The agent filed a confident report on work, it never did it. So every one of these problems that I've listed out here is a real production failure, not hypothetical. These are actual bugs in your on-call rotation. LangGraph exists because someone hit every one of these problems and decided to fix the infrastructure, not just the prompt. Think of LangChain like an assembly line in a factory. Widget goes in one hand, comes out the other. Great for making one thing one way every time. But what happens when the widget is defective halfway through? The whole line stops. There is no go back to the station 3 button. Now think of LangGraph on the other side is like a subway system. So you have got multiple lines, transfer stations, express routes, local stops, and so on. If one line is down, you reroute. If you miss your stop, you loop back. And at every station, there is a map that knows exactly where you are. Now, this is not the LangChain being bad, it's about choosing the right set of tools. A screwdriver is not worse than a drill, they are for different jobs. On the left hand side, it's predictable, simple. On the right hand side, it's dynamic, resilient. That's what LangGraph is. So imagine your agent is a traveler walking through a building. So they have got a backpack, that's the state. Everything they know, everything they have collected, it's in that backpack. So this is what the state exactly means. Then talking about the nodes, nodes are the rooms in the building. Each room has a job. One room calls the LLM, another room calls a tool, Another room checks if we are done. The traveler walks in, opens the backpack, does the work, puts the result back in, and moves on. Next is the edges. Edges in the line graph are hallways connecting the rooms. Some hallways are straight, you always go from room A to room B, but some hallways have a sign that says check your backpack first. Now, those are conditional edges. So, they read the state, decide which room you go to the next. So think about state. It is a typed class. It could be typed dict or pydantic, not a loose dictionary. This is what makes it a production grade. So you get validation, you get autocomplete, you get clear contracts between the nodes. Let's talk about this fork in the road with a signpost that reads the state. Here is the thing that makes agents actually look very intelligent agent. The ability to look at what they have done so far and decide what to be done next. That's conditional edge. So think of it like a choose your own adventure book. At the end of each chapter, you don't just flip to the next page, you make a choice based on what happened in the story. Now, if you look at the diagram here, agent runs, produces the output, that route sent to the router, router function checks, did we get what we need? If no, route to the call tool, loop back to the agent. If yes, route to the finishing line. Now, this loop is pretty much everything. This is how an agent can try a tool, check the result, realize it needs more info, try another tool, and keep going until the job is actually done. Without this, you're just hoping the first attempt works. Now, this is the difference between a chatbot that says, I don't know, and an agent that says, let me try another approach. And this is what the LangGraph is. Checkpointing. So checkpointing is like save points for your agent. One question I want to ask my audience here. Who here has ever played a game without saving and then died right before the boss? That sick feeling in your stomach. That's what running an agent without checkpointing feels like in production. So checkpointing means that at every single transition, every time your agent moves from node to another, the entire state is automatically saved. And if the process crashes at, let's say, maybe at step 47, you don't restart from step 1. You reload from step 46 and you keep going. Pause and resume. The Your agent is doing a 30-minute research task. Server restarts at, let's say, maybe minute 25. Without checkpointing, 25 minutes are wasted. With checkpointing, picks up right where it left off. Second most important superpower that's given to the LangGraph, time travel debug. Something went wrong, let's say at step 12, rewind to step 11, inspect the state, see exactly what the agent was thinking. It's like having a DVR for your agent's brain. Scale horizontally. That's the third superpower. Start on machine A, continue on machine B. The state lives in the checkpoint store, not in the memory. And this is a real production differentiator that makes it memorable. Let's take a look at your agent can stop and ask for permission. Now, one thing I want to talk to my audience here, a uncomfortable truth. That's nobody tells or nobody trusts a fully autonomous AI agent with their money, maybe with their data or with their reputation. And they shouldn't, of course, not yet. The agents that actually get deployed in enterprises are the ones that know when to stop and when to ask for permissions. Now, because we have checkpointing, adding a human approval gate is trivial. The agent hits the gate, saves its state, sends a notification to a human, waits, could be 5 seconds, could be 5 hours, and when the human approves, the agent picks up exactly where it left off. No context loss, no state corruption, and so on. So the agent is about to send, let's say, maybe $50,000 payment. It pauses, shows the human, I'm about to send $50,000 to vendor X. Do you really approve this? Human either clicks yes or he says no. If he clicks yes, yeah, task is done by agent. Now, next, my another maybe a example. The agent drafted a customer email. Before it sends, human is going to review the tone, fixes the typo, approves it, and then agent sends it. Third example. Let's say the agent wants to delete 10,000 rows from a database. It stops, shows the query to the human being. Human says, absolutely not. I don't agree with this. Agent takes a different path then. Now, this isn't a limitation. It's a feature. It's what get an AI agent past legal, compliance, and maybe your VP's anxiety. Let's take a look at and understand how do we want to run this agent in production at serious scale. I know what you're thinking. Cool framework, but is anyone actually using this in production? Let me answer that with numbers. So we are moving from chatbots to autonomous workflow systems, and orchestration frameworks like LangGraph are becoming the operating system of that transition. 90 million plus monthly downloads. That's not hobbies. That's engineering teams shipping the real products. 27,000 plus monthly searches. So people are actively looking for this. The demand is real. 1.0 plus stable since October 2025. This isn't the beta software, it's the battle tested software. Uber is using this for agent orchestration, Klarna for their customer service automation, LinkedIn, JP Morgan, BlackRock. Now, these are the companies where it crashed and lost it is not an acceptable incident report. So, if anyone here who works in fintech, healthcare, or enterprise, these names do matter. These are really regulated industries where reliability is not an optional thing, it's a mandatory thing. Well, I'm going to say something that might surprise you. Don't use LangGraph for everything. And seriously, if you're building a simple RAG pipeline, retrieve some docs, generate an answer, done. LangGraph is overkill there. It's like driving a Formula One car to the grocery store. Well, you can, but why? Okay, let's take a look at on the left hand side. You want to build a simple QA bot. LangChain works best. Maybe linear pipeline. Absolutely, LangChain works best. No loops, no branching, no human approval needed. Go for LangChain. It's simpler, faster to build, easier to debug for straightforward flows. Now, but the moment your agent needs to retry, maybe do branching, wait for human, or survive the crash, that's when you graduate to LangGraph. And in my personal experience, most production agents eventually need at least one of these. A quick question to all of the audience who are listening to me today. How many of you are building something that needs loops or human approval? Well, that's why we are here. That's what LangGraph provides you today. Okay, all right. Theory is over. Let's build something. I'm going to show you how to go from zero to a production ready stateful agent in 6 steps. Let's go on. Define a type state. First, we define what our agent knows, not a dictionary, a proper typed class. This gives us validation, IDE support, and clear contracts. Add your nodes is the second step. So each node is just a function. It takes state in, does the work, and returns the updates. Simple. Third step, you wire the edges, you connect the dots, tell the graph start here, end there. Here is how to get between the nodes, and so on. Next step, step 4, is where you can add conditional edge. This is where it gets interesting. So we add a router that checks, are we done? If not, loop back. Next, step 5 is where you will attach a checkpointer. One line of code, suddenly your agent can pause, resume, and survive crashes. Step 6, resume and inspect in Studio, kill it mid run, restart, pick it up exactly where it left off. Everything we discussed so far sounds powerful in theory. Now let's see how surprisingly little code it takes to build a resilient AI workflows. And this is what we are going to build today. So we are going to build this one graph, which is a real decision-making system, where we are also going to incorporate the human gate, which is going to survive any kind of the failure scenarios. Okay, which maintains this durable state. So let's take a look at. Uh, First step is looking up the order, fetch the order information. Then let's say if the customer is asking for the refund, check the policy. If the refunded amount is less than or equal to $50, yeah, we are defining auto refund. Refund will be automatically issued. But if return window is outside the return window, maybe greater than 30 days, then policy is going to deny automatically. And then let's say if the amount itself is greater than $50, um, based on the condition, either we want to approve it or deny it. So in the event uh, human says approve, the refund will be issued. In the event human says deny, the refund will be denied. Okay, and most importantly, if you look at this check marked box here, that's the check pointed. So the state is saved before pausing. So you either kill the process, restart, it will resume from the state where it has lost the thing. Okay, that means it's going to completely survive the restart. All right. So today I'm going to use SQLite Saver, but in the real production system, maybe you can save that state to PostgreSQL, and that's what makes it to be the real production system. Cool. Let's go ahead and build this, and we can see this in action right away. All right. As we already talked about and looked at the diagram, let's come back with the scenario. So scenario here is simple, a small production shape LangGraph agent that we want to build it. And this is going to be a production grade AI agent. Now what we are going to showcase here is state, nodes, edges, conditional edge or fork. There's human in the loop involved, checkpointing, which allows pausing, resuming from the state where the state was lost. The customer is going to ask for refund. The LangGraph is going to look for the order, check the return policy, then either auto refund small amounts or it's going to pause for a human to approve larger ones. The whole run is checkpointed so it can survive the crash and resume exactly where it got stopped. And if you look at, there is something called as a checkpoint memory where we are storing everything inside the SQLite database, which is going to survive any kind of the crash or anything. Now, I'm going to do one thing. I'm going to quickly run my agent. Let's take a look at what the agent is going to do in this case. All right. And as we can clearly see here, what I have done, I have run the agent, and if, as you can see, the refund amount is less than or equal to $50, it is automatically approving the request, and it says the refund request is received and it's already approved. But on the another side, if the refund request is maybe more than $50, or maybe if it is beyond 30 days, and that is where it's sending the request to the human for it to approve it. And based on the human approval, whether it's approved or denied, the request is going to be proceeded accordingly. And that's what is going to happen here. So as you can see, for every step, for every refund request, it's waiting for the human approval, and this is what we ultimately wanted. And let's assume if the server crashes or something happens to the server, What happens in that case? What happens in that real scenario? What do you think? Maybe we want the state to persist, and that's what our ultimate goal should be, isn't it? And that's what is going to happen here as well. So let's take a look at that. What will happen in that scenario? So I'll just go back to my directory will activate my virtual environment, and maybe I'll run the demo. And there you go. You can see it's going to wait for the approval. And if approval is, maybe I'm assuming my system got crashed. All right. Since my system got crashed, what happens to that workflow? Will it move on, or will it maybe start from the place where request was in the pending state? Let's take a look at that as well. So maybe I'll go back to my directory. I'll start my virtual environment and let's try to run that. And there you go. You can see it has started from the place where it had stopped it. Okay. And as you can see, based on the human approval, human has already given the decision and the refund has been approved now. And that's what is the most important thing in the LangGraph is. So even if your server crashes because the state is going to be stored in the memory, we always are going to be ensured of one thing, that's my state is never going to be lost. And this is one very crucial and the most important thing in this demo I wanted to showcase. All right, and let's take a look at the another way of looking at this thing. So if my refund is within $50, as you can see, the request will be automatically approved. In both the cases, the request is getting automatically approved. And in the event, let's say, the refund request is more than that, then in that case, it's going to wait for human to approve it. And let's go back. And in this case, what the human will do, he will either approve it or he will deny it. If the request if the human says approved, the refund request will be approved and it will automatically proceed for refunding. And in the event, let's say if the human says, hey, I'm going to decline it through the email, he will either say approve or deny. I'm going to say deny, the refund is denied. So it's going to say your refund request is denied because human did not approve it. Similar way, if the noise can, there's another request for noise cancelling headphones, and I can open this. I can either deny this or I can approve this. If I deny it, you can see the refund is denied in this case. And same way, there's also a scenario for auto denied request. So let's say if the request is beyond the refund window, the return window, it's going to automatically get denied. So this is the LangGraph workflow which I have defined in my code itself. All right. And most importantly, we want to trace down each and every request. And that's where this observability tool is going to help us out with this. So I'm using the hotel collector, which is collecting all the important metrics. And through this Jagger UI, I'm able to trace each and every request that's been made. And you can see this clearly. We have each and every request getting traced. So for example, if I go back to the recent denial, I can trace this out and I can understand as to what's going on. Okay, so through this, I'm able to go deeper into each and every request that's been made, whether it's policy eligible, not eligible, and what happened to that workflow, what happened to that particular step. I can be able to trace down each and every step here. And there you go. You can see order found true. Hotel scope name is refund agent, and we are able to trace down each and every request that's been done by my agent. And this is one of the production grade workflow that we are basically going to basically showing it over here. Cool. So, four things I want you to walk away with here is if you remember nothing else from today, remember these four things. Chains are lines, graphs are maps, different tools for different problems, state, nodes, edges, that's it. The whole mental model fits on a napkin. Checkpointing is production superpower. Without it, you are building sandcastles at high tide. Use LangGraph when you need it. Don't use it when you don't. Be honest about which ones you are building. If you walked in confused about when to use LangGraph versus LangChain, I hope that's crystal clear now. Found this useful? Subscribe to the next one. That's it. You now know more about LangGraph than 90% of developers who claim to be building AI agents. If this was useful, smash that subscribe button. Next session, we are going to go deeper into multi-agent orchestration where multiple graphs talk to each other. Drop a comment below telling me what you're building. I read every single one, and the best question becomes future videos. Thank you so much. Hope you enjoyed the session today.